Reehal here. I'm going to do the AP Calculus exam free response question, AB 2007 question 3. This question had about an average of 0.96 out of 9, which is one of the lowest scoring AP Calculus exams FRQs in history. Although, if you really look at this question, it's not too difficult, so we're going to hop right in. Part A is asking, explain why there must be a value r for 1 is less than r, which is less than 3, such that h of r equals -5. So this already sounds like an intermediate value theorem problem. We want to show h of r equals -5 on this interval 1 is less than r, which is less than 3. And so I've already written down h of x equals f of g of x minus 6, because College Board gave this to you in the first part of the question. And since we're looking on this interval 1 and 3, that's what we want to plug in as x. I've already written that, so we're just going to go ahead and plug that in. So we have f of g of 1 minus 6. So we're going to go ahead and look back at the table and find g of 1. So we have g of x. We have x is 1. That's 2. So we're going to plug 2 in. F of 2 minus 6 equals, now we have to go look what f of 2 is. F of x, 2, 9. So we're going to do 9 minus 6 equals 3. So that's what h of 1 equals. Now same thing with h of 3. F of g of 3 minus 6 equals, do a little minus sign. So we're going to look what g of 3 is. You got g of x, you have 3, that's 4. So we're going to plug in 4. F of 4 minus 6 equals, look what f of 4 is. We have f of x, 4, and that is going to be -1. So -1 minus -6 equals a -7. So since h of x is differentiable on this closed interval, it's therefore going to be continuous on h of 3 is less than -5, which is going to be less than h of 1. So by the intermediate value theorem, h of r equals -5 for some value on 1 of and 3. So this is part A. We're going to go ahead and move on to part B. So part B is asking, explain why there must be a value c for 1 is less than c, which is less than 3, such that h prime of c equals -5. So h is differentiable on the closed interval and it's continuous. So that indicates mean value theorem. So this is a mean value theorem question. We want to show h prime of c equals -5 on this interval 1 and 3. So to do this, we just do the mean value theorem. So we have h prime of c. We're still looking on interval 1 and 3, so we do h of 3 minus h of 1 over 3 minus 1. So we already solved for h of 3 and h of 1 in part A of the question. H of 3 was -7, h of 1 was 3. So -7 minus 3 over 2, -10, okay, -10 over 2, and that equals -5. Now, since we showed h prime of c equals -5, we could go ahead and explain why. So we're going to do this. Since h is continuous and it's differentiable by the mean value theorem. C exists on 1 comma C is less than 3 such that H prime of C equals -5. So that is part B of the problem. We're going to go ahead and move on to part C. So part C is saying let W be the function given by W of x equals the integral g of x and 1 to f of t dt. Find the value of W prime 3. So just the way to rewrite that is saying W prime of x equals f of g of x. Then we have to do the chain rule. G prime of x. So we're just going to plug in 3. W prime of 3 equals f of g of 3 times g prime of 3. So we're going to go ahead and look what g of 3 is on the table. G of x, 3, 4. So it's going to be 4. F of 4, we still have to times that by g prime of 3. We're going to go ahead and look what g prime of 3 is on the table. G prime of 3 is going to be 2. So we're going to go ahead and plug in 2. F of 4 times 2. Now I gotta look what f of 4 is. F of x, the x is 4, is going to be -1. So that equals -1 times 2 equals -2. So now we just say W prime of 3. W prime of 3 equals -2. And that's going to be your final answer. Now move on to the last part, part D. So part D, if g to the power of -1 is the inverse function of g, write an equation for the line tangent to the graph of y equals g to the -1x at x equals 2. So we already know that g prime of b equals 1 over f prime of a. So we're really looking at g of x at x equals 1. So the normal equation for this would be, since x is 1, the y is 2, 1 comma 2. However, we're looking at the inverse. So the y and x are going to switch. So it's going to be 2, 1. So on this point, on y equals g to the -1x is 2, 1. The slope is 1 over g prime of 1. So we're going to go ahead and look what 1 over g prime of 1 is. G prime of x, the x is 1, it's 5. So we know the slope is going to be 1 over 5. So now we know our x is 2, our y is 1, and our slope's 1 over 5. So now we just have to write the tangent line equation. So tan line equals y minus 1, which equals 1/5 x minus 2. So this is going to be your final answer for part D. And that is the question AB 2007-3 from the AP Calculus exam. Thanks for watching, and I hope you understand the question.